I recorded this podcast almost 3 years, more than 3 years ago, but then I just noticed that there's a little too much wind noise in the recording, especially at the end. So I decided to redo it. I'm back in the same building where I leave the windows and doors open because I don't run the AC and it's very hot in Mumbai, and that creates breeze noise. So right now I'm sweating and closed the door to avoid cross breeze. So let's try this again. Mitigating climate disruption in time. A self-consistent approach for avoiding both near-term and long-term global warming. What does this mean? We'll see immediately what it means. It's talking about non-CO2 short-lived climate pollutants, which are, if you remove them, you will get a spike in warming, and there has been a recent paper arguing that the cleaning up of the air over Eastern Asia, China, has actually contributed to the rapid warming recently. So in the long term, that will be needed if we want to be very effective about decarbonization and climate mitigation, global warming targets, and so on. So the significance of this study clarifies the need for comprehensive CO2 and non-CO2 mitigation approaches to address both near-term and long-term warming. Non-CO2 greenhouse gases are responsible for nearly half of all climate forcing from greenhouse gases. However, the importance of non-CO2 pollutants, in particular short-lived climate pollutants, in climate mitigation has been underrepresented. And historical emissions are partitioned into fossil fuel and non-fossil fuel related sources. We can find that nearly half of the positive forcing from FF fossil fuel and land use change sources of CO2 emissions has been masked by co-emission of cooling aerosols. So CO2 increased warming happened, but non-CO2 or aerosols, which scatter sunlight, actually have compensated somewhat for that warming, so they masked the warming by CO2. Pairing decarbonization with mitigation measures targeting non-CO2 pollutants is essential for limiting not only near-term, so next 25-year warming, but also the 2100 warming to stay below 2 degrees C with some 67% probability. To read the scientific abstract as opposed to the significance, which is a tradition in the proceedings of the National Academies of Sciences Journal of the US, the ongoing and projected impacts from human-induced climate change highlight the need for mitigation approaches to limit warming in both the near term, so before 2050, and the long term, so after 2050. We clarify the role of non-CO2 greenhouse gases and aerosols in the context of near-term and long-term climate mitigation, as well as the net effect of decarbonization strategies targeting fossil fuel phase out by 2050. So obviously we are got a tunnel vision on fossil fuel and carbon, CO2, but a lot of the other non-CO2 pollutants are not getting enough attention. Relying on Intergovernmental Panel on Climate Change, IPCC radiative forcing, we show that the net historical, so 2019 to 1750, in other words, how we started building CO2 from 1750 to 2019 and trapping more energy. So that radiative forcing effect of CO2 and non-CO2 climate forces emitted by FF sources plus the CO2 emitted by land use changes is comparable to the net from non-CO2 climate forces emitted by non-fossil fuel sources, right? We find that the mitigation measures that target only decarbonization are essential for strong long-term cooling, but can result in weak near-term warming due to unmasking of the cooling effect of co-emitted aerosols. So you remove the cooling effect immediately if you clean up the air, and lead to temperatures exceeding 2 degrees C before 2050. That might scare you, but in contrast, pairing decarbonization with additional mitigation measures targeting short-lived climate pollutants and N2O, which is a very strong greenhouse gas, slows the rate of warming a decade or two earlier than decarbonization alone and avoids the 2 degree C threshold altogether. these non-CO2 targeted measures, when combined with decarbonization, can provide net cooling by 2030 and reduce the rate of warming from 2030 to 2050 by about 50%. Okay, so that's roughly half of that comes from methane, significantly larger than decarbonization alone over this time frame. Okay, so non-CO2 targeted measures, when combined with decarbonization, can provide net cooling by 2030 and reduce the rate of warming from 2030 to 2050 by about 50%. Our analysis demonstrates the need for a comprehensive CO2 and targeted non-CO2 mitigation approach to address both near-term and long-term impacts of climate disruption. Okay, that's the main message. There are some details in terms of looking at past radiative forcings and future radiative forcings to make these points more forcefully. So here we are, positive radiative forcing from long-lived greenhouse gases in orange, long-lived as they say sometimes in the US. This is 2011 relative to 1750, which was published in the Assessment Report 5, which was released in 2014. Net forcing there from the increased greenhouse gases was 2.4 watts per meter squared, but positive forcing is actually 3.7 watts per meter squared, because you had a negative forcing from these non-CO2 climate pollutants and aerosols of minus 1.3 watts per meter squared. So you can see the numbers there, 50% from CO2, methane and ozone, black carbon and HFCs, CFCs and N2O at various percentages making up the rest of it. If you look at 2019 relative to 1750, which was published in AR6, which got released around 21-22 because of COVID, delayed a bit, but net forcing up to 2.7 watts per meter squared with positive forcing of 4.1 watts per meter squared, and the net negative forcing jumping to minus 1.4 watts per meter squared, slightly above the previous number of 2011, but these numbers come with lots of uncertainties. Nonetheless, CO2 went up to 52% here, methane up, black carbon down, HFCs up, CFCs down slightly, and N2O remains almost the same with all the uncertainties. If you imagine 2100 relative to 2019 from one of the scenarios, which is the Shared Socioeconomic Pathway 3-7.0, I've discussed what these mean elsewhere. You can follow up. The net forcing would be 4.3 watts per meter squared, so still going up, and positive forcing would be 4.6 watts per meter squared for this pathway, and cooling aerosols of 5% here with negative forcing of minus 0.29 watts per meter squared. Okay, so basically that means when we do non-CO2 cleanup, we will end up with removing the cooling effect, which may appear to be a bad idea, but we'll see that in the end ends up sharply reducing the warming rates, okay, if not the warming itself, and that's essentially what we want to aim for, to slow down the warming as well, because the overshoots will happen anyways. Well, we don't want to say anyways, but we'll keep trying to avoid them, but right now it doesn't look too promising, right? I want to be optimistic, but nonetheless. So positive radiative forcing from long-lived GHGs, short-lived GHGs, GHG precursors, and black carbon, so aerosol radiation interaction, and so albedo effects only. There's always caveats in the IPCC assessment, and negative forcing from individual aerosol direct effects, so aerosol radiation interactions, scattering effects, and total aerosol indirect effects, so aerosol impacts on cloud properties, optical properties, etc. Okay, so to look a bit more at the contributions to 2019 radiative forcing from emissions by fossil fuel, CO2 plus non-CO2 sources, and CO2 from land use changes, so forestry, other land use, FOLU, sometimes it's called AFOLU as well, agriculture, forestry, other land use, but nonetheless, so there are fossil fuel CO2 and non-CO2, and non-fossil fuel CO2 and non-CO2 radiative agents, compared with emission of non-fossil fuel, non-CO2 sources based on one of the references, and you can just see the numbers. 2019 relative to 1750, net forcing from fossil fuel CO2 plus non-CO2 and FOLU CO2, land use change, forestry and other land use change, positive forcing of 2.5 watts per meter square. So the negative forcing is obviously minus 1.1 watts per meter squared. On the other hand, non-fossil fuel, non-CO2 net forcing is at 1.2 watts per meter squared and a positive forcing of 1.4 watts per meter squared. So here you have methane, black carbon, HFC, CFC and N2O, and the negative forcing of minus 0.22 watts per meter squared. If you look at the same thing for 2100, you end up with net forcing of 3.1 and positive forcing of 3.2, calling aerosols of here contributing a little bit, but CO2 fossil fuel adding 85% of the forcing. So negative forcing here minus 0.12 watts per meter squared, and this is non-fossil fuel, non-CO2 forcing net 1.3, similar, very similar to the 2019 numbers, and positive forcing at 1.5 watts per meter squared, very similar. So here negative forcing from fossil fuel sources and land use minus 0.12 watts per meter squared, and negative forcing from non-fossil fuel forcing at minus 0.25 watts per meter squared. So these are again based on SSP 3.7 for the future. There are lots of uncertainties in the emissions pathways themselves, because when you go to 2100, all the uncertainties here come from the scenarios themselves, with all our assumptions about populations, technologies, energy sources, policies, and options, and also these particular scenarios say whether we are choosing the most benign pathway to stay under 1.5, or we are going gangbusters using fossil fuel as much as we want and hoping to just mitigate our way out of climate change and so on. Okay, so the main idea here then, historical and future temperature projections through 2050 calculated using RXM energy balance model based on emission scenarios from the SSP database for reference scenario SSP 3-7.0, decarbonization driven mitigation scenarios, which is this study, and an decarb plus targeted scenario to include aggressive decarbonization and targeted short-lived climate pollutant mitigation. So that's adapted from SSP 1-1.9. So historical curve or past simulated warming is from the figure summary for policymakers SPM 8.A from IPCC AR6, and rate of warming in degrees Celsius per decade. So essentially you are looking at warming itself relative to 1850 to 1900 baseline in the cases of historical mean, where where we were when the paper got published, with the 5%, 95% bandwidth here, and this is the decarb driven warming till 2050 or so here, and you can see if you do decarb plus targeted mitigation of SLCPs, you reduce the warming, but it's much more impressive when you look at the warming rate changes. So this is warming rates in degrees C per decade. So by 2050, you are going to reduce the warming rates of the reference case versus the decarb driven case versus decarb plus targeted mitigation of SLCPs. You drop to warming rate of 0.10 degrees C per decade by 2050 here, even though there is initial warming of a little bit, but the other ones, reference case, will stay at almost 0.4 degrees C per decade. You can do the numbers as to where you will end up by 2100, right? So we'll easily cross the 2 degrees C target, and in the decarb driven case you will come down to only 0.25. So it's a change from there, but compared to this, it's really worth thinking about doing this targeted additional mitigation of SLCPs, which is not getting enough attention in the entire discussion on decarbonization and mitigation. Mitigation does give attention to non-CO2 greenhouse gases, methane, N2O, HFCs, CFCs, etc. But the short-lived climate pollutants don't necessarily get so much attention. Okay, so a good caveat, a good warning to pay attention to the entire problem, especially because when we say net zero, we are mostly talking about carbon alone, not necessarily the non-CO2 greenhouse gases. So even if you reach carbon net zero by 2050, the non-CO2 greenhouse gases will keep the greenhouse gas warming going for a while. So by the time we reach total CO2 equivalent net zero, so CO2 equivalent will include non-CO2 greenhouse gases as well, and then of course there are the non-CO2 short-lived climate pollutants like black carbon and other aerosols that we mentioned. Okay, so just keep in mind, I'm putting this in carbon capture because it's decarbonization and mitigation overall. Okay, let me leave it here.